Hello, everyone. Hi. Hello. Welcome to the final session on day one of the Global Innovator Summit. This session is titled User-Centered Design and Older Adults as Drivers of Innovation, a discussion with the Catalyst Award winners. My name is Liz Salmi, and I will be the moderator for this session. For those who don't know me, I'm the Communications and Patient Initiatives Director for Open Notes at Beth Israel Deaconess Medical Center in Boston, Massachusetts. My early career was rooted in design and user experience, but it wasn't until after my own cancer diagnosis 15 years ago that I was drawn to work in healthcare. Today, my work involves partnering with diverse stakeholders in the prioritization and design of research, and I especially enjoy working with older adults in this process. Today, you're going to hear from 5 Healthy Longevity Catalyst awardees from around the world, all of whom have incorporated user-centered design principles in their work. But first, for those of you who are not aware of user-centered design, I want to speak briefly about this approach and why it's particularly important in the realm of healthcare and technology. So here's a little bit of background. User-centered design is a creative approach to problem solving that starts with the people you're designing for and then ends with solutions that meets the needs of that population of people. In this case, the needs of older adults. When you understand the needs of the people you are trying to reach and understand from their perspectives, you, as the designer or the researcher, you may arrive at unexpected solutions and answers to research questions as you come up with these ideas that your target populations might embrace and actually use, which is key. The presenters today are all focusing on designing and creating solutions for older adults and the challenges that older adults face. So now I'm going to turn to the Catalyst awardees so you can hear from them and learn about their work. I'm going to go in alphabetical order by last name. And as I introduce each person, they will tell us about the project and how it incorporates user-centered design principles. And then once everyone has had a chance to speak, we'll transition to more of a discussion. All right. Yay. So first, let's hear from Dr. Yi-Cheng Liao, the Catalyst awardee from Academia Sinica in Taiwan, on their project titled Connected Speech Analysis in an Elderly Population. Dr. Liao, on to you.
Yeah, hi, everybody. I still would like to use my slide to introduce our project. Basically, our project is try to analyze the connected speech of elderly people. So, especially, we would like to do the early detection of Alzheimer's disease. I think for many researchers, it's a very important thing to do. And basically, for a doctor, usually we measure the short-term memory. However, I think that the language part is always missing. It's always forget. So what we want to do is use the language material to analyze and to do the early detection. What we do is we analyze we do the picture description for people, and we collect the language material, and we try to analyze this language material. By far, we use 16 linguistic features, and we try to analyze this linguistic feature, and 6 of them is very promising. I think we can achieve a very high accuracy on separating the MCI and the normal subject. So I think this is what our team is doing now, and we also maybe we also find a connection between these linguistic features and the hippocampus size and the other cognitive outcome. So I think it's quite interesting that using language as a study material to understand the cognition. So that's what we do. It's just a very short introduction about what we are doing in Taiwan. Yeah.
Thank you so much. That was so fast. I wasn't expecting it to be so fast. Thank you for keeping on time. That was excellent. Thank you. I appreciate that. Well, I'm going to turn on to the next Catalyst awardee. I'm going to turn to Dr. Marcos Zuniga, the Catalyst awardee from Chile's National Agency for Research and Development on their project, An Integral Telehealth Solution for Elderly Care, integrating video conferencing and automatic detection of vital signs through artificial vision. That sounds really interesting. I'll pass it on to you.
Thank you. I wanted to share a presentation. Maybe I can right now. Yeah, I can. Can you see it?
Looks like it's coming up. There we go.
We're okay?
Yes, I can see it.
Great. So, well, we aim at providing remote medical solutions to reduce the risk of physical contact with the patient as equivalent as possible to a physical medical meeting. In the third world, as in Chile, this is a critical aspect, as hospital and medical centers are already saturated with the long waiting list and a significant risk of hospital-acquired infections. The idea of the project is then to provide an integral telemedicine platform for elderly care where the patient's vital signs are automatically monitored through artificial vision during a telemedicine session. In general, the system is composed of two modules, one on computer vision inference server, which receives video clip session, processes video estimating vital signs, and responds with estimation to the client. Vital signs inference service is the other model that controls the interaction with the users and makes the video call. And I will try to be brief, so I will go a little bit quick. In this phase, we were able to analyze the whole state of the art, analyzing the techniques for automatic estimation of heart rate, respiration rate, oxygen saturation, and blood pressure, implemented the most suitable techniques for each vital sign, and we generated a validation test data set of more than 100 smartphone videos simulating a telemedicine session with emphasis in elderly people, with more than 50% of these people over 60 years old. Also, vitals from medical devices were taken with a pulse oximeters and blood pressure monitor to effectively validate the capability of automation of these techniques. We have found out that most of the existing techniques were validated in ideal conditions. So they expected slight movement on the patient, normal vital signs, or ideal illumination conditions. And we know in telemedicine, this is not all the time the case. Normally, we have people moving, or it's not that easy then to process videos as we expected. But nevertheless, we obtained pretty promising results. For you to understand the problem, it's very important to see that hemoglobin only changes plus or less than 4 levels from 256 levels. So it's a very slight color change to be detected. So illumination changes can be can really condemn a good result from this type of algorithms. Also, we have learned that a significant number of deep learning techniques based on data sets with normal conditions. So abnormal vital sign conditions were not present in the data set, so they weren't able to detect them. Nevertheless, we were able to make a full systems interacting with elderly people for a very simple interface for acquiring the videos for processing. They only have to position themselves in this kind of image. I don't know if you can see the video. I hope so.
Yes.
Good. And well, we have very promising results. We are still evaluating, and there are lots of videos we had to process, but we are in the range of medical interest of different measures. Heart rate is the best one, which not more than 15 levels of heart rate are as medicals have said, enough to say if they have abnormal or normal situation, and with a high accuracy on effectively detecting normal or abnormal situations. But in the blood pressure and the oxygen saturation, we have found out based on machine learning techniques that the data set, as I have said, had this problem of not containing abnormal situations. So they are not able to make the difference properly, which is the interest of having vital sign estimation automatically from the telemedicine application. So we are advancing on this. This is the first year of work. We just try to characterize what is available now, and is in the next phase we will be facing the challenge of improving these results. We think that photoplethysmography is very important to characterize electrocardiograms will be very important as information to characterize properly abnormal situations too, and we don't have this information yet, so we will have to collaborate with different organizations in order to acquire this information. And we are searching for a simple protocol for every user, with emphasis in the elderly, and improve the protocol for minimal recording requirements is one of our priorities. So the team is a big team, but I wanted to focus on the associates, which is
Dr. Zuniga, I believe I'm supposed to move on to the next presenter, if that's all right with you. Fantastic presentation, and it was really cool to see your prototype like in action right there. So thank you for sharing that.
Good.
And
Thank you.
I'm moving on to the next presenter. Next, we're going to hear from Professor Victor Li. He's the Catalyst Awardee of the Chinese University of Hong Kong and the University of Hong Kong on their project titled A Directed Graph Neural Network-Based Drug Repurposing Approach to Identify a Lead Combination of Drugs for Alzheimer's Disease. I'm going to pass it over to you to Professor Li.